Welcome to EDU World Space.
Problem 7.72, we have a small rock with mass of 0.12 kilograms. It's fastened to a massless string with length 0.8 meters to form a pendulum. And so the pendulum is swinging, so it makes a maximum angle of 45 degrees with the vertical. We have air resistance is negligible. First, we're asked what is the speed of the rock when a string passes through the vertical position. So here I'm going to define our potential energy to gravity to be 0 at the base. So that means that we have just gravitational potential at the top here, and it's going to turn into all kinetic energy at the base here. So we have gravitational potential equal to K2. I'll write down this as 0.1 and this is 0.2. So then we find out what those are. So we have mg times some height, I'll write as y, and that's going to be equal to 1/2 mass velocity squared. I'll immediately cancel out the mass. But what we need to find is y in order to find what our speed is at the bottom. Okay, so we need a little geometry here. So the pendulum forms a triangle between our length when it's at 45-degree angle and with the vertical. That's going to be a right triangle. So I need to find what this is. This is y. So I know that this whole length is L, but in order to find what this length is, what I can then do is say L minus this length is going to be y. So to find this length, I know that the hypotenuse is L. I have an angle, so I can find what the adjacent angle is. So that's L cosine of 45 degrees. So then y equals our full length, L, minus this partial length, L cosine 45 degrees. Okay, so then I can substitute that in for y. So I have g times L. I can immediately just pull that out. And I have 1 minus cosine of 45 degrees. And that's going to equal to 1/2 velocity squared. Okay, so then I get v is equal to square root of 2g L 1 minus cosine of 45 degrees. Okay, so then all that's remaining here is numbers. 2 times 9.81 times 0.8 meters times 1 minus cosine of 45. So then I get that v is equal to 2.144 meters per second. So that's part A. Part B, we are asked to find what is the tension of the spring when it makes an angle of 45 degrees with the vertical. Okay, so for this, we need to set up a free body diagram. So a free body diagram basically just takes our point, and their point here, and we assign all the forces that are on it. So at a 45-degree angle, we have our tension, and directed straight downward is our mass times gravity. So what we can do is we need to find what the tension is spring there in the string there. So since these are only forces acting on it, I'm going to find what tension is by finding out what is equal and opposite to, because we know that the string is not stretching or pulling in the mass at all. It's forming a circle. So the acceleration is in this direction. That means that the tension is going to equal and opposite to whatever component of gravity is in that direction. So that is just going to be the same thing we've done before with the cosine of 45-degree angle right there. So we write that tension. We can write down our sum of forces. We have mg cosine of 45 is equal to tension. Okay, and then that's going to be equal to our 0.83 newtons. Okay, then for point C, we do the same thing. For question C, we can do the same thing. At point 2, we have our tension, and we have gravity straight downward. We're not accelerating up or down, so that means that we have tension is equal and opposite to the mass times acceleration of gravity. So we have tension equal to mg, and that's going to be equal to 0.2 times 9.81, 1.18 newtons. And it's going to be a solution.